rectangular components of force. With this example, we'll try to understand how to find the magnitude of rectangular components of a force. The question is, resolve a 100 Newton force into two equal rectangular vector components. Now we will adopt two strategies here and see what are the alternate ways of finding the components of a force. When we say components of a force, that means we are splitting a force into two other forces whose combined effect is the same as the given force or the original force. So those two are called the components of a force. And when we are saying rectangular components, we are saying that the two components are at 90 degrees to one another, forming a rectangle or a right triangle. So let's have 100 Newton force along this line. Let's say this vector represents 100 Newton force. Now, to resolve it into rectangular vector components, we can draw lines which are horizontal and vertical, right? So the horizontal line from the tail and the vertical line from the head. So when we draw this, they will intersect at a point, and this point will always be at 90 degrees. Now in this process, we have actually resolved our force into two components. So we have a component along the horizontal and we have a component along the vertical. So these are the two components, and when you add them up, you get the original force, right? So both are equal. The two components sum and the original force. So that is the strategy behind it. So let me call this horizontal component as Fx and the vertical component as Fy. So this is a force acting along the horizontal direction, and Fy is the force acting along the y direction, and the combined effect of these two is the force which is given to us, and in this case it is 100 newtons. Now to find Fx and Fy, we can use Pythagorean theorem, which is Fx square plus Fy square is equals to 100 square. That is one way of doing it. And the second way is we can use trigonometric ratios if we know this angle theta, right? So in general, in any such problem, in general, if you see this kind of a right triangle, then Fx is the adjacent side and 100 given to us, the resultant in this case, or the original force, is the hypotenuse, right? So you can write cos of theta as equals to, in this case, Fx, the horizontal component, magnitude, divided by the hypotenuse, which is 100. So from here, we get the horizontal component, and that is Fx, the horizontal component, will be equals to 100 times cos of theta, right? How about the vertical component? Vertical component is opposite to theta, right? So we'll write sine theta as equals to opposite side, which is magnitude of Fy over 100. So from here, we can get magnitude of the vertical component Fy is equals to 100 times sine theta. So this is a very general solution which I am coming up with, and then we will later talk about two equal components, right? First, I want to give you a basic approach to this kind of problem, right? Now, so we get what each component is in terms of original given force or vector, right? So that is the geometric approach to this. Now the other thing is, we can use Pythagorean theorem, that is f of x, which is the horizontal component square plus Fy magnitude along the vertical square is equals to 100 square. So we can find x and y from this relation also, right? Provided we are given the angle or some other parameter. In our case, what are we given? It says resolve a 100 Newton force into two equal rectangular components, right? That means fx is equals to fy. The magnitudes are same, right? So now, as given in our case, equal components, that means fx is equals to fy, and therefore we can write fy also as fx, correct? So what do we get? We get 2 times fx, right? So let me first write them as fx. So both magnitudes are same, right? So we get fx square plus fx square, which is 2 times magnitude along any one direction. We chose it along horizontal for the time being, 100 square. And now what is fx from here? We will do, this is the horizontal component, right? It's a good nomenclature to represent fx along the horizontal and fy along the vertical, where x and y are subscripts, right? So they always indicate the direction. So it is helpful. So fx is 100 square divided by 2 square root. So when you do that, you get 100 over square root 2. So the magnitude of each component in this case is 100 over square root 2, right? So that is your answer for both fx and fy. Okay? Both are same. Now if you are doing trigonometric approach, and if I say that these sides are equal, in that case these angles should be equal, right? So in that case theta should be equal to 45 degrees. Now if theta is 45 degrees, then we can find both the components. So what do we get? So we will get fx, the horizontal component, is equals to 100 times cos of 45 degrees, which is equals to 100 times 1 over square root 2, which is same as we got with Pythagorean theorem, right? Similarly, fy, the vertical component, will also be 100 times sine of 45 degrees, right? Since the angle theta for us is 45 degrees, right? In that case, this 45 degrees is 1 over square root 2. So we get the same answer, 100 over square root 2, right? So the two equal components for a 100 Newton force will be 100 divided by square root 2, correct? It is normally better to rationalize it. And then if we rationalize it, that means multiply and divide by square root 2 and then write down the answer. Let me show you rationalization here on the side. So if we have answer like 100 over square root 2, rationalizing means multiplying and dividing by square root 2, right? So it gives you 100 square root 2 over 2, which is equals to 50, because this 2 and 2, square root 2 times square root 2 is 2, so 100 divided by 2 is 50 square root 2. So that's an alternate way or a better way of writing your answer. So we will write them as 50 square root 2. So we see that the horizontal component is 50 square root 2, the magnitude, and the vertical component magnitude is also 50 square root 2 if angle theta is equals to 45 degrees. That ensures that the magnitude of the resolved components is exactly same, right? I hope you understand with this how to resolve force into its components. So we started with a very general solution. The theta could be any angle. Since it was given to us as they are equal, so we took both sides as equal, and that is possible if the triangle's angles are also equal, right? So 90 divided by 2 gives us 45, and that's how we get 45 degrees. And in Pythagorean theorem, we selected fx equals to fy and solved for one to get the other. So that is how we can actually resolve a force into its components And this strategy is going to really help us in solving many problems and applications involving force. So we'll exploit those in coming videos. I hope you appreciate it. Thank you.